Hi, welcome back to Mr. Silver's Math. Today we're going to talk about graphing quadratics. Specifically, we're going to get into the vocab that you're going to need in order to graph said functions. So we're going to start with just some evaluation because we're going to be evaluating a lot this unit. So let's get our mind thinking about evaluation again. So our warm-up is just evaluate the following when x is 0. So anywhere I see an x, I'm going to substitute in. I'm going to plug in a 0, and then I'm going to follow the order of operations. So after the substitution, I'll do the exponents first. That's first in my order of operations. And then I'll do the multiplication, and then finally I'll do the subtraction. So I get 0 plus 0 minus 12 equals -12. Letter B, same thing, substitute in 0 where I see an x. This time I've got parentheses and I got to work with what's inside of them first. 0 plus 4 is 4. Then I can do the squared. 4 squared is 16 times 2. And then subtract 8, I get 24. A quadratic equation or a quadratic function has the highest power of 2. Quadratic equation or function forms a parabola when graphed. So it's going to look like the letter U or the letter N. There are three different forms of quadratic functions. We will talk about all three later in the unit, but today we're just introducing concepts and vocab. So the vertex, think of the top or the bottom of a graph. If you don't like math, think of the top or the bottom of a roller coaster, where it gets to the very top. As you go up and then all of a sudden you'll start to go down, that would be the turning points. So that would be your vertex. Same thing on the bottom where you bottom out and then all of a sudden you're going down and then you're almost like you're floating because then you go back up. The turning point of the parabola is the vertex. It's the point where the parabola changes directions. It's written as an ordered pair. So this example here, called the parent function, my vertex is right there, changes direction right there at 0, 0. The minimum, think the bottom of the roller coaster. This is the smallest or the lowest output produced by the quadratic function. It occurs at the vertex when the parabola opens up. So specific to this graph, this right here, 0 is my minimum. There is no graph below 0. Okay, my function is not graphed below 0, so that's why I have a minimum of 0. It is also the y value of your vertex. The maximum, think the top of the roller coaster, this is the highest or the largest output produced by the quadratic function. It occurs at the vertex when the parabola opens down. And the graph looks like a letter N. It is written as the y value of the vertex. So if I relate it to the graph that I just looked at, this graph has no maximum. Right? This is a minimum. You can't have a minimum and a maximum. This has no maximum because these arrows are, well, those are arrows, so they're pointing up. It means it keeps going infinitely. So there is no maximum on this particular graph. Axis of symmetry. It is the vertical line, or it is a vertical line. It goes through the vertex. So a vertical line, once again, is straight up and down. It is written as an equation of a vertical line, so it's always x equals, and then it's x equals whatever your x value is of your vertex. And then finally, we have intercepts. One is the y-intercept and one is the x-intercept. So the y-intercept is where it crosses the y-axis. You can have 0 y-intercepts or 1 y-intercepts. Chances are you're always going to have one. There's I can't think of one where you encounter where it would be 0, so you're always going to have one y-intercept. Your ordered pair is always 0, comma, and then where it crosses the y-axis. Your x-intercept is the point where the parabola crosses the x-axis. You can have 0 x-intercepts, you can have 1 x-intercept, or you can have 2. And it doesn't necessarily have to just cross, it could just touch the axis. Same thing for the y-intercept. It could just touch the y-axis, not necessarily cross. So example 1 is asking you to answer the questions below. So my vertex is right there. It's at the top. So I went left 1 and up 4. So that's why my vertex is -1, 4. It's opening down. It looks like a frown, open down. So because it's opening down, that means I have a maximum. And my maximum is coming from my y value. And I have a little note here that says you only need to fill out one of them. So that's why I cross off the minimum. You can't have a minimum and a maximum. Your axis of symmetry is always x equals, and in this case it's x equals your x value of your vertex. That's why I have the color coordination going on here. Your y-intercept is where it crosses the y-axis, so that is your vertical axis, where it's crossing that y-axis. And then your x-intercept is where it's crossing the x-axis. In this case, there are 2, and you need to actually list both. Don't just list one of them. And then letter B is the same idea. So identify your vertex. I went left 2 and then up 2, so that's why it's at -2, 2. This time it's opening up, so I have no maximum. My axis of symmetry is x equals -2, so I'm taking the x value of my vertex and putting it with my axis of symmetry. My y-intercept, where it crosses the y-axis, is at 0, 6. And I have no x-intercept, so you write none. Okay, don't leave it blank. Don't write 0, 0. Okay, if it does not cross the x-axis, you write none. There's no x-intercept. And then example 2 is just more examples. So you can try those on your own and then come back and check your answer to see how you did. But once again, I want to stress that you cannot have a minimum and a maximum. You have one or the other. Axis of symmetry is always x equals because it's a vertical line. And if you have intercepts, they are